Hence, there is no hindrance in the movement of the electrons, and therefore the gas conducts electricity.
When a high voltage is applied between the electrodes, apart from the usual cathode rays emerging from the perforations, you will see that some rays are coming from the side of the anode as well. These rays, after passing through the perforated cathode, strike the zinc sulfide coating, and a red glow is observed on the glass wall.
These rays are called as the anode rays because they originate from the anode.
These rays are also called as the canal rays because they pass through the canals, that is, the holes in the cathode.
These rays travel in the direction opposite to that of the cathode rays.
Let us study about the origin of the anode rays.
We know that the cathode rays consist of a stream of electrons. When a high voltage is applied, these electrons move towards the anode with a very high speed. When these fast-moving electrons strike the gaseous atoms, they knock off the electrons. This results in the formation of the positively charged ions. These positively charged ions move towards the perforated cathode and constitute the beam of the anode rays coming through the holes of the cathode.
Now, let us discuss some of the properties of the anode rays.
The anode rays travel in a straight line. When an object is placed in the path of the anode rays, a sharp shadow is produced on the glass wall.
The anode rays are made up of material particles. If a light paddle wheel is placed in the path of the anode rays, the wheel begins to rotate.
The anode rays carry positive charge. When an electric field is applied, the anode rays are deflected towards the negative plate of the electric field. This shows that the charged particles in the anode rays carry positive charge, and therefore the anode rays are also called as positive rays. When a magnetic field is applied by bringing the south pole of a magnet near the discharge tube, the anode rays are deflected towards the magnet. On reversing the magnet, we observe that the rays are deflected in the opposite direction. It shows that the anode rays carry positive charge.
The properties of the anode rays depend upon the nature of the gas taken in the discharge tube.
The mass of the particles that constitutes the anode rays is different for different gases taken in the discharge tube. When hydrogen gas is taken in the discharge tube, lightest positive ions called protons are produced. A proton is produced when one electron is removed from the hydrogen atom, and it is about 1840 times massive than an electron.
After studying the various properties of the anode rays, it is clear that the anode rays are made up of material particles and they carry positive charge. The positively charged material particles constituting the anode rays are called protons.
So, we can conclude that protons are the basic constituents of all the atoms.